Welcome to an asynchronous day where we're going to be talking about um, making sure you feel good about climate change and the carbon cycle for what we've covered so far. So just a reminder that last week we talked about how Earth receives solar radiation from the sun, some of which is reflected back out into space by clouds or Earth's surface, but a lot of it is absorbed as heat energy on the surface, and that surface temperature, as it increases, can release radiation that can cause the greenhouse gas effect. And Earth about absorbs 100 grams or 100 watts of solar radiation per meter squared. So if we get into 40, we're releasing about 140. Now, in terms of greenhouse gases, carbon dioxide is obviously the one that we are worried the most about because it's the most common, but there are other types of greenhouse gases that also cause Earth to retain heat. Methane, nitrous oxide, fluorinated gases, all are more powerful than carbon dioxide. So within our atmosphere, they all contribute towards Earth retaining heat. Now, normally the cycle is quite even, and it hasn't changed that much, but due to recent human activities, we're seeing all of these greenhouse gas concentrations really increase quite dramatically, which is causing us to really think about, as Earth's surface heats up and that heat is released back into the atmosphere, how are changes in Earth's surfaces and also Earth's cycle is going to impact and also sort of co-create with the carbon cycle some really big issues that we care about when it comes to water quality, soil quality, weather, climate, and our ability to live comfortably on this planet. So just a reminder that when we talk about soil health with also thinking about water in the ground, that good parts of the world are experiencing desertification, where we are losing healthy soil, healthy nutrients, and available water. And at the same time, huge parts of the planet are being deforested for things like commodities, agriculture, forestry, and even wildfires due to changes in climate and weather. And not only that, but when we think about another major type of surface on Earth, ice, there's huge retreats in the glaciers in mountain ranges, as well as the ice sheets in the Arctic and Antarctic Circle. And our question really is thinking about how do these changes impact the carbon cycle, and vice versa. How does the CO2 changes impact these cycles as well? Now, when it comes to the carbon cycle, a really important thing to know is that before human activity, we were sort of at a net zero when it came to the number of gigatons in the atmosphere of carbon. About 800 gigatons or 800 billion tons of carbon dioxide is stored in Earth's atmosphere. And every year, about 120 gigatons are removed from Earth's atmosphere due to photosynthesis, while at the same time, plants breathing during the winter and also soil living and breaking down things release 120 gigatons. So 60 and 60 in, 120 out. We're sort of at net zero when it comes to the fluxes of carbon dioxide. And when we go over to the other large flux between reservoirs, we look at 90 gigatons of carbon dioxide going into the ocean, mostly for phytoplankton photosynthesis. That phytoplankton will die or decompose or be eaten by larger fish, and all of that respiration and decomposition will release about 90 gigatons back out. So again, a net zero in terms of 90 in and 90 out. But humans have been actively contributing towards fossil fuel consumption, and that has led to an annual increase of about 4 gigatons of CO2 in Earth's atmosphere per year. We're burning a lot of stored carbon that's inert and far from the active reservoirs and fluxes, with driving cars, burning coal, generating electricity. Now, this extra 9 gigatons of CO2 doesn't seem like a lot, but only 3 of that 9 can be taken back in to plants, while only about 2 of the extra 9 can be added to the oceans. So we're left with 4 gigatons, 4 billion tons of CO2 per year that's adding to this increased concentration. But as we deforest, have soil degradation, and water quality goes down, these numbers likely will drop because there will be less biomass and less resilient ecosystems to store this extra CO2. So these graphs will likely have steeper and steeper curves. So why does this matter? Well, greenhouse gas effect is based on a variety of factors. It's not just the amount of insulation in the jacket. It also has to really do with what are the materials on the surface that reflect that heat. So albedo is a measurement of how well Earth initially reflects that sunlight back into space. Solar radiation, UV light, is not really able to interact with carbon dioxide in the atmosphere, which means all of this solar radiation that we're able to reflect back off into space at initial contact isn't going to contribute to greenhouse gases. What does contribute to greenhouse gases is all of this heat radiation that's absorbed by the sunlight. Think about the asphalt on a hot day. And as that heat leaves the surface, it radiates back into the atmosphere, which can interact with greenhouse gases. And when that radiation interacts with a CO2 molecule, it bounces back down into the surface, reheating the Earth. So it's a positive feedback loop of more surface temperatures causing more radiation, and more radiation causing more heating of the surface of the Earth. And there's surfaces that are really good and really bad when it comes to absorbing that initial solar radiation and causing radiation. So with your activity today, you're really going to be making observations about how changes in Earth's atmosphere is contributing to changes in carbon and also weather and climate. So when we look in this document, Carbon Modeling with Net Logo, it's important that you read over these basic parameters of the test. This is a really good explanation of what's going on within the actual model. And then you're going to be taking some trials. For now, don't worry about collecting data here. I'm far more worried about your ability to describe changes, make predictions, put the graph in here, and analyze it. So we're going to first set up the game as if it was the normal Earth. So normal Earth's average albedo is about 0.3. I'll do 0.35. We have about 425 parts per million when it comes to CO2. And I'm going to add a few clouds. And I'm going to press go. And we'll notice as sunlight comes in, heat goes up. Pretty soon we'll start to see red dots come off, which is going to be the heat radiation that's being lost from the high surface energy. And it's going to be interacting with CO2 molecules and bouncing back up. And it's causing a pretty steady increase in CO2 concentrations. Now, it looks like I've leveled off at about 40 degrees. So I'm going to press go because it's going to pause the game. And I'm going to now make a change. I am going to say humans get their act together and CO2 concentrations reduced by half. The tick number is at 4632. That's the time, and my prediction is I'm assuming temperature is going to drop by 10 degrees. So I'm going to go back in. I'm going to change my CO2 concentrations to about 175. I'm going to press go, and I'll see what happens. Now, interestingly, initially, there's no change in temperature because I have all of that heat that's still stored in the surface of the Earth. So what's going to be probably happening is I'm going to have fluctuations up and down where I lose some heat, gain some heat, lose some heat, gain some heat. But notice I'm not seeing the initial temperature loss that I initially would have thought. There's this oscillation of where we store some heat, lose some heat. Because we still have CO2, it's hard to get rid of that solar radiation. So you are going to do 5 of these, where you're then going to also take a screenshot of your graph and also analyze what's going on in your model. What changed the temperature, the radiation, the amount of sunlight, anything that's useful for that. I hope this helps, and I will see you guys on Thursday.